Hello everyone. Welcome back to my channel Physics Hub Official, where we make science simple and interesting. In today's video, we're going to learn about one of the most important topics in chemistry, Dalton's atomic theory. Before we begin, let's travel back in time to the early 1800s, when scientists were still trying to understand what matter is really made of. It was then that an English chemist named John Dalton proposed a revolutionary idea, Dalton's atomic theory, which became the foundation of modern chemistry. Dalton suggested that all matter is made up of tiny particles called atoms. He believed that these atoms are indivisible and indestructible, and that they combine in different ways to form all the substances around us. In simple words, everything you see, touch, or feel is made of atoms. Let's understand the main points, or postulates of Dalton's atomic theory one by one. Every matter is made up of atoms. Atoms are the smallest particles that take part in chemical reactions. Atoms are indivisible. They cannot be created, destroyed, or broken down by chemical means. All atoms of the same element are identical. For example, every hydrogen atom is the same as any other hydrogen atom. Atoms of different elements differ in mass and properties. That means, an oxygen atom and a hydrogen atom are completely different. Atoms combine in simple whole number ratios to form compounds. For example, one molecule of water is always made of two hydrogen atoms and one oxygen atom. The ratio of hydrogen to oxygen is a fixed 2:1. Dalton's atomic theory also explains some important laws of chemical reactions, such as: first, law of conservation of mass, means matter cannot be created or destroyed. Second, law of constant proportion, means a compound always contains the same elements in the same proportion. Third, law of multiple proportion, means when two elements form more than one compound, the ratios of the masses are simple whole numbers. Fourth, law of reciprocal proportion, means elements that combine with a fixed mass of a third element also combine with each other in simple ratios. However, Dalton's atomic theory was not perfect. It had some limitations. It could not explain the existence of isotopes, atoms of the same element that have different masses. Isotopes have different masses. Isotopes of the same element have the same number of protons but different numbers of neutrons in their nucleus, which gives them different mass numbers. Example: hydrogen, for instance, has 3 isotopes: protium, 1 proton, 0 neutrons; deuterium, 1 proton, 1 neutron; and tritium, 1 proton, 2 neutrons. All are hydrogen, but they have different masses, which Dalton's theory cannot explain. It did not describe the internal structure of the atom. Example: internal structure of hydrogen. Later discoveries showed that atoms are divisible and contain subatomic particles like electrons, protons, and neutrons. Even though Dalton's atomic theory had some drawbacks, it was the first scientific model that explained the nature of matter in a logical way. It laid the foundation for modern atomic models that came later, like Thomson's, Rutherford's, and Bohr's atomic models. So, we can say that Dalton's work was the beginning of the atomic age. If you found this video helpful, don't forget to like, share, and subscribe for more science lessons. And comment below, which part of Dalton's theory do you find most interesting? Thanks for watching. See you in the next video.